Here's the single loop circuit that we just solved, and as I had mentioned at the time, I replaced the dependent source with an independent 4-volt source just because we haven't talked about dependent sources yet. What I want to do now is to modify this problem so that we include the dependent source. So we'll just mark over here in a red pen what things will change. So a dependent source is drawn with a triangle instead of a circle, and you can have dependent voltage or current sources, and they can depend, basically their value depends on some other variable in the circuit. So it could be dependent on another voltage, it could be dependent on another current, and there's typically some scaling factor. So in this case, what we're told is that the voltage that this source produces is 4 times whatever the voltage Vx is. Okay, so when we write KVL, we won't write 4 volts because we don't have 4 volts there. Instead, initially we're going to write 4 times Vx. We have no idea what Vx is yet. Right? Now, in the next step here, second step, we express what Vx is. Vx is equal to minus 30 times I. All right? And that's based on the fact this is plus and this is minus. If the sign had been flipped, then it would be plus 30 times I. So all we're going to do is we are going to replace 4Vx with 4 times minus 30 times I. So that's minus 120 times I. And here we're going to have a change. Then we won't have 8. We just have minus 12. Right? Before we had minus 12 plus 4. Here we have just minus 12. And we're going to add in minus 120 here. Right? Because just like for the other resistors, we had 8, 7, and 30 being dependent on or being multiplied by I. We now have minus 120. So we can combine all of this, and we would have, instead, we'll have 12 divided by 8 plus 7 is 15 minus 120. We'll have a minus 105. Oh, I'm sorry, I did my arithmetic wrong. This would be over 8 plus 7 is 15 plus 30 is 45. 45 minus 120 would be 75, I think. Yes, 75 minus 75. Okay, so dependent source might be intimidating at first, but we just kind of took it at one step at a time, and as long as you can express that dependent signal, in this case Vx, 4 times Vx, as long as you can express Vx in terms of the unknown current, you can proceed with the same method to find the unknown current I, and then the voltages or powers, whatever the case may be.